All right, so we're back with question 11. And so this one, just one more multiplying. Then the rest of this video will be factoring. So multiplying the polynomials, just so you know, when you see this, it's going to be 3x plus 4. When it says squared, that really means you have to write it twice. So this time, if you want to make the box, feel free to do the box. This time, I'm just going to draw arrows. So here's what I see. I see the 3x. You have to do the first. So the first is 3x times 3x. That gives me 9x squared. Oh, and there's the puppies. Then I'm going to do the outside. So that 3x has to multiply by the 4 as well. So outside gives me plus 12x. Then the insides are going to give me 4 times 3x. So that's another 12x. And then last but not least, the last is going to be plus 16. So when you see the word FOIL, really what that means is first, outside, inside, last. Don't forget you can put these two together. So my final answer, 9x squared plus 24x plus 16. Now, there is a pattern in how this works. And if you see it, what I notice is that 3x times 4 gives me 12x. And there's two sets of that. So I can just double it and get 24x in the middle. If that makes sense, awesome, you see the pattern. If not, just write it out every time and come up with a solution. All right, now let's go to factoring. So the factoring piece, this is going to be a big part of your test. There's going to be at least 5 factoring kind of like this one. But you're also going to have to look at one like 12. So factor the expression. There's only 2 pieces, and there's an x to the third in there. Goodness gracious, what am I going to do? Just so you know, my puppies are having a battle over there. One weighs 10 pounds, and one weighs, like 6 pounds. And my phone is buzzing. But hey, that's just part of making videos at the Beaver household at night. So, let's see. I've only got 2 pieces. And so I'm going to think, what could I take out of everything first? So I look at 18 and 4. What can come out of 18 and 4? I think I can divide each by 2. Then I look at the x's, x to the third and x squared. I can take an x squared out of both of them. So I'm going to write 2x squared. That's what I could pull out of both. What is left? Well, if I take 2x squared out of 18, if I divide that out, 18 divided by 2 is 9. X to the third divided by x squared is just x. Then I see a minus sign, so I write the minus sign. 4 divided by 2 is 2. X squared divided by x squared is just 1, so I can leave it at 2. So 2x squared times 9x minus 2. Awesome. All right, the next, x squared plus 11x plus 30. There are a couple of different ways that we thought about this. First of all, x squared. What multiplies to give me x squared? X and x. Then what multiplies to give me 30, but adds to give me 11x? When we very first remembered how to do this, we wrote it like this. What adds to give me 11, but multiplies to give me 30? And so you might see it right away. If you don't, here's what happens. I figure out what multiplies to give me 30. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Which ones of those adds up to give me 11? Oh, that would be 5 and 6. So now, that gives me 5x. 6x makes 11x. So x plus 5, x plus 6. Most of you can do that without quite so much work. A lot of you can now just look at that and say, oh, 5 and 6. Multiply to give me 30, add to give me 11. All right, so let's look at this one. Factor the expression x squared minus 6x. So what's different about this one? This minus here. Oops. So let's see. The x squared, so x and x. What multiplies to give me 16, but adds to give me negative 6. Maybe you see it right away, but I've got 1 and 16, 2 and 8, and 4 and 4. Which one? Yep, 2 and 8. Okay, and I've got to get negative 6, so this is 2x 8x, so which one's got to be negative? X minus 8. X minus 2. Nope. What's wrong? Got it. Plus 2. Okay. Now, this one, I see it starts with 3, and I don't necessarily like that. So let's see if 3 comes out of everything to make it easier. Oh, hey, look, it does. So I can pull 3 out of everything. If that's the case, I'm going to write 3 out here. What is left? X squared plus 11x plus 18. Okay. Can I always pull a 3 out? Not always, just in this case because it comes out of everything. Now, let's see. What multiplies to give me 18 but adds to give me 11? 2 and 9. So my final solution is x and 2, x and 9. Don't forget that 3. And everything is plus. So plus, plus. There you go. That 3 pulling out in the front is super important. If you can do that, you for sure should. All right, now let's see this one. I've got a 6 out front. Can I pull a 6 out of everything? And the answer is no. So this one is going to look a little bit different. Okay, so I'm going to need something that multiplies up to negative 6. But over here, I have to pull this apart as well, because do you see how that's not just a regular x squared? So I have to come up with, how do I make 6x squared? Well, I can do 1x times 6x, or I could do 2x times 3x. Then over here, what's going to give me 6? Now it's negative, so that means one's going to end up being negative, one's going to be positive. You always keep your x's positive, but over here, my constants, I can be 1 positive, 1 negative. So 1 and 6 or 2 and 3. All right, now I just kind of have to guess and check until I get it. And what's going to happen is I'm going to multiply these two together and these two together, and whatever's here has to add up to 5x. So you think through it, push pause until you get it. I need to push pause because I'm not sure what the answer is. All right, now I found it, so I'm going to try it, and I'm going to use the right answers, but I'm going to put them in the wrong order just to see if you can kind of follow what I'm doing. So this first one, right away, I'll tell you right now it's wrong. So if you need to skip over it to check your right answer, you can. But sometimes, so I know it's going to be this one and this one. And so let's see. I'm going to put 2x and 3x. And so I want to multiply so that they're 5, but the signs can be opposite. So 2 and 3. So if I multiply 3x times 2, I get 6x, and 2x times 3 is 6x. Oh, darn it. That's not right. If it's not right, that's totally fine. Then you just go in. That's why we use pencil. Just go in and erase this stuff. And then I just try it the other way. So I think that I want to do 3x times 3 and 2x times 2. If I do that, I get 9x right here when I multiply those two, and 4x right here. Do those go together to give me 5? The answer is yes, because I know one has to be positive, one has to be negative. So the 9 has to be the gain, the 4 has to be the loss, which means the plus goes right here, the minus goes here. Okay, now, first and first. So when I put my solution together, I'm going to do it over here. I'm going to get 2x. You have to keep that 2x. You can't just go to x and x. 2x plus 3. And then 3x. Now I do the second and the second. 3x minus 2. There is my solution. All right, this next one is actually, I think, easier. Simply because 3x, there's only one way to get there. It's 1x and 3x. The 7, there's only one way to get there. I just have to decide which order. Now I want to get my middle to equal up to 22. So which, if it's going to be 1 and 7, what do I multiply by the 3? 7, because that gives me 21x's, and 1. That gives me 1x There it is. Whoop. So I'm just going to do, so first and first, but instead of writing 1x, I'm going to just write x, and it's a plus plus, so plus 7, and then second, 3x plus 1. You can write a 1x, but just as you get further along, you can skip the 1. It's just less clunky. So x plus 7 times 3x plus 1 is just as good, if not better, than 1x plus 7 and 3x plus 1. All right, what do we got here? Factor this. Oh, I love it. Okay, look at the clock. What do you see? 49, 7, and 7. So what multiplies to give you negative 49 but adds to give you 0 because the middle's gone? X plus 7, x minus 7. That's a difference of squares. Maybe make a note to self, look for perfect squares. This one, oh, the same thing happens. However, look, I see perfect square, but if you come up with 2x, and 8 and 8, so 2x plus 8, 2x minus 8, that will give you half credit. Because look at 2 and 8, 2 and 8, something pulls out of there. What pulls out of 4 and 64 first? This is not a bad answer, it's only half credit though, because you haven't simplified all the way down. Kind of like if you told me 4 eighths, I would say, oh, that's 1/2. So I can pull a 4 out first and get x squared minus 16. So my best answer, 4 times x plus 4, x minus 4. And I could have pulled a 2 out of here and a 2 out of here, so that could give me the 4, and then x plus 4, x minus 4. All right, almost done. One more question. Oh, 2. Factor this expression. Oh gosh, that's super nice. 100. Right away, what do you think on 100? I think 10 and 10. So I'm going to go with x and 10, x and 10. But you get a 20x in the middle, so what do you know about both of the signs? Instead of being one of each difference of squares, these are just, it is the squares. So there you go, x plus 10, x plus 10. You could also, if you wanted to, write that as x plus 10 all squared. All right, last one. It's a word problem, but it's not any different. X squared plus 4x minus 12. Okay, so x and x. What multiplies to give you negative 12 but adds to give you 4? 6 and 2. Who has to have the gain? So x plus 6, x minus 2. All right, is that in there? Yep, it's in a different order. Does it matter? Nope, because the commutative property says it doesn't matter what order you multiply in. There you go. That's the second part of chapter 8. Those are all super important questions. There will be about 17 from this chapter on your actual final test. So make sure you get good notes and you get good practice.